For section 2.2 day 1, in example 1, our directions are to state the number of possible real zeros and turning points, and then determine all real zeros by factoring. This is example 1, letter B. We're going to do this problem with f of x is equal to x to the fourth minus 3x squared minus 10. Well, we're supposed to determine the maximum number of possible real zeros. And again, the number of possible real zeros, that maximum number, is whatever your highest power of x is. So in this case, x to the fourth is the highest power of x. So there are 4 possible x-intercepts. There are 4 possible real zeros. And your maximum number of possible turning points that's always 1 less than that. So the possible turning points has a maximum of 3. The number of possible real zeros is 4. From there, we are supposed to go through and factor this and find all of our real zeros. So again, whenever you're finding real zeros, you're finding x-intercepts. And to find an x-intercept, you plug 0 in for y, which is what this f of x is. It's just a fancy y equals. So our equation is going to be 0 is equal to x to the fourth minus 3x squared minus 10. That looks a little different than a lot of the problems that we were working on before with our review with this x to the fourth and x squared, but that's okay. If we follow our factoring steps, we should be able to get to the right answer at the end. First step in factoring this right side is to factor out what's in common. We don't have anything. If I count the number of terms, I see that there are 3. That tells me that if this is going to factor, we're going to need to do that add multiply process. Your add number is the coefficient of this middle term, which is a -3 this time, and your multiply number, that's this constant on the end, times the number in front of the lead term. Even though our lead term is an x to the fourth, it's still the number in front. So -10 times that invisible 1 gives me a -10. There are a couple of numbers that do fit that pattern. They are -5 and 2. And from there, I should be able to go through and do some factoring. I'm not sure if I can use this shortcut or not. I do have a 1 in front of the x to the fourth, but we haven't factored anything like this before. So if possible, we'd like to use the shortcut. I just don't know if it is or not. We haven't talked about that yet. So I'm going to do this the long way. I'm going to write down the first term, and then I'm going to split this middle term up into 2 parts. This middle term is an x squared term, which means when I write it here and split it up into those 2 parts, both of these are going to need to be x squareds also. So whatever your term is here, when you break it up into 2 parts, it has to be that same type of term. I'm going to have a -5 x squared and a +2 x squared because of our numbers that we found. So breaking up that middle term, a -5 x squared and a +2 x squared. And then I can just copy that last term down. From there, we go through and try to factor these 4 terms by grouping, if possible. The first 2 terms do have an x squared in common, and if I factor them out in front, I have an x squared minus 5 in the parentheses. The last 2 terms have a 2 in common. I could either factor out a positive or a -2, but because this first term here in this last group is positive, I'm going to factor out a +2. When I do that, I have an x squared minus 5 in those parentheses also, which does match the other set, and that means that this did factor. It factored into an x squared minus 5, our match set, and then the other set of parentheses are what we factored in front, which is an x squared and a +2. Remember that all of that way back at the beginning here was equal to 0. I could put 0 equals in front, but when we solve, we typically put the 0 over on the other side. So I'll just switch that around. And now I have something that I can go through and solve and find the real zeros. There will be a maximum of 4 of them. We know that. We just don't know how many there will be, and we don't know what they are exactly. We have 2 things being multiplied together that equals 0. In order for us to solve that, we just set each one of those parts equal to 0. So the first set of parentheses is an x squared minus 5. We'll set that equal to 0. X squared plus 2 equals 0 is our other equation. And if we solve both of those, we will need to, in this first equation, add 5 on both sides. That gives me x squared is equal to 5. When I go through and solve this for x, I do need to get rid of the squared here, so I will have to do the square root on both sides. When I do the square root on both sides, remember that there is a plus or minus there. Anytime you're doing a square root on both sides of your equal sign, you have to remember that's going to give you two answers. Now we have to put that plus or minus there. The square root of x squared is x. And here our two answers are a positive square root of 5 and a negative square root of 5. We want to simplify the square root of 5 if we can, but that does not simplify at all. So we do end up with two answers from that first equation. X is equal to a positive square root of 5. X is equal to a negative square root of 5. Now I'm ready to solve the other equation and see if we have any more real zeros. I'm going to subtract 2 on both sides. That will give me an x squared is equal to a negative 2. To get rid of the squared, I'm going to do the square root on both sides. And again, I do need to remember to put in that plus or minus. So what we're going to end up with is x is equal to plus or minus the square root of a negative 2. If you remember correctly, square root of a negative is not a real number. We could go through and simplify this. We would need to use an I in order to do that. And there are some problems at some point in the book where they will say find all of the real zeros. You'll need to find all of the real zeros, and you'll also have to find all of the imaginary zeros. But the directions for this problem were only to find the real zeros. And the two zeros that we get here are actually not real. So these are not real. They are imaginary. And the directions were find the real zeros. So we are not going to include these in our list of real zeros. Our real zeros for this problem are just a positive square root of 5 and a negative square root of 5. So you could list those out separately with a comma, or if you want, you could keep the notation like we have here with the plus or minus. There was a maximum of 4 possible real zeros, but we only ended up with 2. The other 2 zeros were actually imaginary numbers. For letter C, we'll take another look at one of those, but this time we'll have it cubed in here. So for letter C, we're going to do the same directions with this equation. F of x is equal to x to the 6th plus 13x cubed plus 40. So to start, we do want to take a look at your highest power of x and determine what the degree of the polynomial is. It's degree 6, and that is also the number of possible real zeros. So there are as many as 6 possible real zeros. Might be less than that. That's a maximum number. We also need to look at the number of possible turning points. And that is always one less than your number of possible real zeros. So there are as many as 5 turning points in this problem. From there, we want to go through and find the real zeros by factoring. That's what the directions said. F of x, when you're finding zeros, you change that into the number 0 because we're finding x-intercepts. And that's what the y-coordinate is of all x-intercepts. And then we have our polynomial, x to the 6th plus 13, x to the 3rd plus 40. From there, factoring. Factor out what's in common. There isn't anything. Count how many terms there are. There are 3. I'm going to try the add multiply method. Again, this looks a little bit different because we have an x to the 6th and an x to the 3rd in here, but if we follow our rules, we still should be able to come up with the answer. Our add number is going to be a positive 13 from that middle term, And our multiply number is 40 times 1, which is 40. So if I can find two numbers that multiply to be 40 and add to be 13, then I will be able to do some factoring on this one more than likely. Our two numbers are 5 and 8. I listed them backwards, that's okay. You just need to list them out. It doesn't matter what order you go through and list those. So 5 and 8 or 8 and 5, those are our two numbers. They fit the pattern. So from there, I'm going to go through and factor this the long way. Again, there's a possibility that maybe the shortcut would work, but we just haven't really factored anything like this, so I'm going to do it the long way. I know for sure that will work. I don't know if the shortcut will or not. This middle term is next to the third term, and I'm going to split it up using these two numbers. So again, both of these need to be x to the third terms because that's what we're breaking up. And I'm going to write this as a plus 8, x to the third, and a plus 5, x to the third, and then copy the last term down. From there, I want to go through and factor by grouping. We have 4 terms now, so I'm going to group. The first two terms have an x to the third in common. And if I factor that out in front, I'll have an x to the third plus 8. The last two terms have a 5 in common. I could do a 5 or a negative 5, but again, this first term here in this group is a plus, so I'm going to factor out a positive 5. I did end up with matching parentheses, so this is factorable. One set of parentheses in our factored form is going to be the match set, and then the other is what we factored in front. Remember that we do have this 0 here, so we are setting that equal to 0 and then solving. I'm going to break this up into our two equations. X cubed plus 8 is equal to 0. That's one of the equations I will need to solve to find some of our real zeros maybe. Might end up with no real zeros there. We don't know. We'll have to find and solve and see. So here's our two equations. Let me go through and solve. I'm going to subtract 8 on both sides to start with. That's going to give me x to the third is equal to negative 8. And then to get rid of the cubed, we do need to do a cube root on both sides. And the two questions we have are, first of all, when you do a cube root, do you have to put the plus or minus in front? And the answer to that is no. You only do that with even roots, like square roots or fourth roots or sixth roots. So when you do a square root, you have to remember the plus or minus, but the 3 here is an odd number, so we do not. So there's no plus or minus in front. And also, you can do cube roots of negatives. These are real numbers. So this is going to give you a real number answer. If you look at your list of perfect cubes, 8 is a perfect cube. It is 2 times 2 times 2. So the cube root of positive 8 would just be 2, and the cube root of negative 8 would just be negative 2. So we end up with x cubed is equal to a negative 2. Sorry, the cubed should be gone. We just did the cube root, so the cube should be gone. So one of our solutions is x is equal to negative 2. I want to do the same thing with the other equation. I'm going to subtract 5 on both sides. That will give me x cubed is equal to the square root of 5. To get rid of the cubed, I am going to do the cube root on both sides. Doesn't matter that there's a negative on the inside, and I also don't need the plus or minus. I just need to simplify this as much as possible. The cube root of 5 does not simplify at all. So this is one of our possible answers, the cube root of a negative 5. Otherwise, when you have an odd index, you can bring the negative in front also. So sometimes you would see it written this way, with the negative in front instead of inside. So it doesn't matter, but we want to have one of those two for your final answers. So if we list out our final answers, negative 2 is one of them, and then our book tends to leave the negative on the inside for this, but it could be written the other way too. So that is our final answer. Negative 2 is one of our real number zeros, and then the other is the cube root of a negative 5.